Thursday. Yeah, exactly. Not Friday morning, you know. So I think timing-wise, perfect. Yeah.
Yep.
All right.
Signaling from the client to the client, you would need client to do the same thing with its own bit to signal loss from client to the server. Those two are totally separate. Right? So, if there is no loss in the direction from the server to the client, you will not see any LBITs. I mean, unless but other direction with its own settings. Its own set of topics. Now, of course, there are spurious ones, right? We decided, oh, the packet was lost, but it was delayed. So you have 50,000, that's better to receive that. Well, sorry. We're already saying that.
So for something you say, we try. Your system together with us with the same flow.
Right.
So we can compare exactly
So you're working on a test net, test simulator to do this.
the simulator using many bits. So we can map square feet.
That is actually very good. That is very good.
With the same flow, some time you see how this is. In our opinion, between the square feet, you if you have 3 bits, so it's the optimum. So we have the pure loss bit, the square feet, and our round trip loss bit.
I'm going to ask everybody.
Life changes. Chasing it around, trying to catch it. So what happens is that they will see on their monitor starting.
The voice
Only in bando.
All right. Good morning, everybody. Thanks for making it out to this chill working group room for the inaugural Mops working group session. I think you're familiar with the note well, and you should note it well. All the usual conditions for participating in the IETF apply. A couple of bits of administrivia. Assuming there are no bashes to the agenda, we have blue sheets that are about ready to circulate. Are circulating, Glenn? That are about to circulate. I understand that we are, and that several people have a conflict with the TSV working group that's on at the same time. So I expect there will be people coming in and going out for different agenda items in either working group. And we've noted that we should make sure not to collide with that working group going forward. So there's that, but it also means that we have a JavaScribe. Thank you, Aaron. But we don't actually have a notes taker at this point. Is there anybody willing to be a note taker for this session, please? Don't all volunteer at once. Thank you, Ronnie. Okay, great. Thank you very much. We can move on. So are there any bashes to the agenda that's been posted for a week or so? Assuming not, moving on. Yeah, so this is our inaugural working group meeting. We have met several times before in multiple contexts and different guises. So I just wanted to remind people of what our charter says. There's a lot of soliciting of input here and regular updates. So this is the general area of focus for this working group. And what we're gonna talk about this morning has a lot to do with updates from various. I suppose I'm actually supposed to stand on this pink thing if I'm. Much better. Now I can talk to the microphone stand. So there will be a lot of updates from other areas, from other organizations. One of the things that I want to do with this session, because it is a working group and not just a conference session, is start to work out our mode of operation. So I'm hoping that we will actually have some interactive discussion around some of the things that are presented, in terms of, ask questions about stuff that's being presented on work going on elsewhere. We have one discussion of, an awareness raising with regards to an issue with streaming and Quick. We can have a discussion after that presentation about, is there further follow on? What do we think about it? So on and so forth. So generally speaking, just all that to say that this really should be I'm hoping this will be an interactive session, notwithstanding the fact that it is Thursday morning after a very long week. Thankfully, it's not Friday morning after a very long week. Okay, all right. So unless there's any questions so far, yeah, this is just a further note about my earlier point about what we're here to do. Our outputs are meant to be some documents, the presentations that get posted in proceedings for all to see, and also potentially some dispatch-like activities where we might refer people to other working groups. That last aspect, I think, will be particularly useful when we have people who, join our efforts from other organizations who may not know where to go in the IETF, or may not know where to take their work within the IETF. So that's sort of the general context. And that's it for me. So next up, Jake.
Hi, I'm Jake Holland, and I was going to give an update on the one document we have so far. Next slide. Okay. So the doc status, I think it went onto the milestones list when we first started the working group or something, but I don't think it's been adopted by the working group. And I'm not sure whether that counts as consensus or not. I guess probably not. Anyway, we probably should discuss that and make a decision. Some of the offline comments last time, there were several supportive comments of the general direction, a few refinements, and a few people seem to indicate that it's not totally clear that the doc is super useful, but I'm not sure whether that means that we should refine it until it's more useful, or that the general concept at all is not necessarily worth writing down. So a little discussion on that would be lovely. Yeah, I haven't actually touched it since posting it last time, but I do have a few. There was some feedback from Ali, so I have a few to-dos to put in there, and I think that the suggestion from Leslie that this is not a taxonomy, it's a operational considerations for media streaming from edges, indicates changing the name as we perhaps adopt it and put it forward. And then there's I would say the kind of most, there is a lot of the feedback I got is that there is one really good insight that it would be great to get in there somehow, which is the sort of mismatch between the capacity and the demand for like large scale events. And, in the sense of presenting it with good archival value, these are the slides that I had last time. I think I've shown them a few times. It's, just the when you take a kind of large scale number, actually we published a new number since then. I probably should have redone the math a little bit. So it would move up by, call it 2.4 million instead. But the core insight is the same. It's just that when you take a sort of large scale provider, just the thing that they're able to do, even a good sized CDN is, it doesn't match the sort of real capacity to consume the popular things from the audience size, even with the demand we have today. And it's not clear, depending which numbers you look at, like how much worse it's getting and how much better it's getting at different times. So the best idea I have on how to capture this in a sort of an insight that applies across time is maybe the trend line with the cumulative annualized growth rate or something. I'm not sure that's good. I would love suggestions on how to do it better. And just other suggestions on what should or should not be in the stock would be very welcome. So that is my update. Do we have any questions, discussion, adoption calls that the chairs would like to perform, etc.?
Thank you, Jake. So maybe we can start with opinions on that last point about what is an actual useful way to explain or articulate the demand versus capacity disconnect that you were describing in this graph. In a useful way that will be worth publishing for archival purposes.
Kyle Rose, Akamai. How about just if you were to unicast all of this traffic, how much bandwidth would that be?
So I put a formula in there, one for how much it is per per stream with unicast, and did a couple of example multiplications to say if you have this many millions of viewers, it means this much bandwidth. It doesn't really make that point in as punchy a way as the mismatch does, right? It just presents the raw number that, if you have 500,000 users, you need 600 gigabits, which may or may not be easy in 2 years' time, or today. It's just the question of, like, there is a mapping, but making the point that there is a mismatch and that the mismatch has been sort of growing and persistent and problematic is the part where I feel like it's weak and could use an improved presentation in a way that still carries some punch, right? With recognition that moving forward, networks change, right? That's like the part that I'm struggling to really communicate in the document. So this is the best idea I've got so far, but I think it could be improved, and I'm looking for suggestions. Yeah. Thank you.
Mark Nottingham, cold. Just thinking out loud, maybe it would help to kind of dive into where you think the constraints are. These are big numbers. But the internet has grown over time, and CDN capacities have grown over time. Is it last mile? Probably not. I mean, at least where I live, everybody's getting 100 megabit and more pretty soon. Is it middle mile? Maybe that's more interesting. Is it CPU? Is it network card? Is it the economics of your peering relationships?
Yeah.
Maybe just unpick those bits might help a little bit.
That's a good point. Thank you. Yeah. In some cases, it is the access networks. In a sense, it is inherently the kind of global provider in some kind of, which may be multiple. Yeah. Thank you. That's a good.
There's another dimension to this, which Dave Oran, which would be really useful to capture, which is that people tend to assume there's a high correlation between the very high demand content and live content. And to some extent, that's true if it's a football game or a rock concert or something like that. But there's other forms of very high demand content, like newly released episodes on Netflix, where pre-placement in caches very close to the edge tremendously ameliorates this bandwidth, unicast bandwidth need, without having to resort to the kind of multicast tricks we use that are needed for live content. That's a second dimension to the problem. I think it's really useful to capture somehow.
Yeah, thank you. I was kind of bundling that under the live versus on-demand comment that I got from Ali last time, but I think that's a helpful refinement. Thank you, Dave.
So Glendine from over here. Maybe even breaking up to two separate charts. One showing sort of the bandwidth requirements for file-based or highly cacheable content. And then a second one that's sort of more live-oriented. Because in particular for the live, I think an additional parameter to try to start catching is latency as well. Because as we evaluate, other approaches, with highly cached content, latency isn't a big deal. Because if you're watching a movie and it takes 5 seconds or 10 or 20 seconds from initiation to your scene, that's fine. But when you're in live content, since it tends to be sports oriented, latency is really critical. And you can't do 20 seconds, you can't do 30 seconds. You need to get 2 to 6 seconds.
Yeah.
And maybe trying to measure that. And the other aspect I was going to suggest was there's this other component here, which is that you get the adaptive bit rates coming into the equation. And so I'm not sure how to capture it, but I think it's important to recognize that these rates are variable even during a session. And there's some ladder and so maybe it's to introduce a standardized ladder for a lot of this content, and then do the charting based upon the because the ladder typically has 3 to 5 rates that you can choose from.
Standardized ladder sounds out of scope for this talk to me, but fascinating idea. Thank you. I do have some text in there about ABR that speaks a little bit to these points. I can't remember it off the top of my head now, but that's I will review and see if that addresses any of your comments. Thank you.
Okay, so I'm hearing engagement at least in this particular point, and it sounds like it would take a bit of document real estate to tease apart some of the possible approaches to answering it. So that sounds to me like there is interest in this document going forward. And to your point about whether or not it's officially a working group document, I think I don't know if I want to try to hum this early in the morning, but perhaps I should. The document is indeed in kind of a strange state because it was adopted as one of the milestones as we went through the chartering process. But on the other hand, we didn't have a formal working group discussion about whether or not we wanted to adopt it. So I guess at this point, I will ask for a hum. Are we in favor of adopting Jake's document and carrying on updates to carry out this discussion over the next, months, 18 months, whatever, to try to tease apart and come up with good articulations of these things? So in favor of adopting the document, please hum now. Against adopting the document as a working group document, please hum now. All right. Thank you all, and thank you, Jake. So what I heard was some hums in favor of adopting the document, and a very little disagreement with adopting it as a sure. And sorry,
could we get maybe a hum for those how many have read it?
Just comment from the Java room. You got 3 hums in favor.
Sorry? 3 hums?
Just 3 additional hums in favor.
Thank you.
Great. Thank you. All right. Anything else?
Seeing no.
Aaron Falk, Akamai, not speaking for Jabber, but for myself. So I confess I have not read the document, but the discussion I thought was caused me to think that there, CDN-based media delivery is a pretty mature area. There are industry standard key performance metrics, and I think to the extent that we can avoid reinventing those in a slightly different way, which will probably cause more confusion than it solves, it's probably a good thing. So I think it's probably a good thing to pull that information into this community, since maybe not everybody here is as familiar with those. But some of the discussion here seemed like pretty well-trod territory in the CDN land, and so maybe we can find some citations that are good sources for that stuff. But
that sounds very useful. If you happen to know any such citations, please send them along. I would very much appreciate it.
You talk to our marketing department at Akamai.
Let's keep it engineering, shall we?
Yeah, so that's a point well taken. Although I will also observe that maybe that's exactly the right answer, and I'm certainly all for not reinventing something that's well shaken out elsewhere. As long as at the end of the day we wind up with something that will communicate to the IETF community something about the scale and scope of problems to be addressed.
Right.
I wasn't trying to imply otherwise. I just think if when we're doing something that if already exists somewhere else, we should probably just suck it in by pound include. I have a comment from the Jabber Room that I wanted to pass on. Chris Lemon says he's read the document. It's got room for improvement. Looks like it's going in a direction that will be useful. With
Excellent.
Chris.
Thank you.
Oh, sorry. Scott Davis also said, I've perused it. I am pretty much aligned with Chris. So 2 more thumbs up.
Excellent. Thank you.
This is on us. Jake, are you looking for co-authors?
If I have any volunteers for co-authors, I would absolutely love to offload some work. Yeah.
I'll take that as a call.
Yes, thank you. That would be lovely. Anybody who wants an RFC on their resume, this one looks like a good path forward. Yeah.
Okay, great, thanks. So when I send to the mailing list that for confirmation that we're adopting this as a working group document, I will say that you would be happy to have a co-author.
Yes, thank you.
Good. So everybody here can think about whether or not they want to help, and you'll have an opportunity to volunteer. Okay.
Thank you.
Thank you very much.
Just a second, Ronnie Evan. I'm doing the notes on the Etherpad, so if anyone wants to.
Okay, thank you, Ronnie. Yeah, so that I didn't put the URL to our Etherpad in my slide deck, but it's on the agenda page anyway. Yeah, if other people are able to join in on the Etherpad and help Ronnie with the notes, that would be awesome. Okay, Warren suggests that we please save the Etherpad every now and then in case it accidentally deletes itself. Okay, Sanjay, please.
All right. Hello, good morning, everybody. My name is Sanjay Mishra. I work at Verizon, but I'm representing as a member of Streaming Video Alliance. So just giving a quick readout on the Streaming Video Alliance's lab initiative. Okay. So the way I want to run the slides are just to give you a quick word or two on what Streaming Video Alliance is and the different working groups within the Streaming Video Alliance, and then kind of jump into the SVA Labs initiative as seen from one of the working groups implementation of it, and then some update on what we have done within the IETF. All right, so 2 things here. One is that Streaming Video Alliance is really nothing but an ecosystem of content providers, content distributors, ISPs, and the network technology vendors working on over-the-top streaming media issues. And by and large, the Alliance depends on IETF protocols pretty much for all aspects of streaming, but also the fact that the ecosystem provides a way for companies with various degrees of experience and expertise kind of work together and work jointly on issues and coming up with best practices or guidelines or in many cases specifications as well. And the next slide, just want to give you a warning. There's a lot of words here. I guess the objective was to see how many words can fit into a slide. So I think that got done, but obviously you can't read anything there. So there are basically a lot of working groups within the Streaming Video Alliance. And just to call out just maybe 1 or 2 or 3 of what the working groups are focusing on. So let's take an example of live streaming working group. They focus on issues like quality, latency, and scalability. Measurement group focuses on QoE. Networking and transport working group focuses on streaming at scale. Privacy and protection group focuses on piracy and content protection, theft, user privacy, etc. So there are various degrees of work that goes on within each of these working groups, and they end up producing, as I said, various levels of documentation. Best practices is one common thing, some specifications and also guidelines based on the experience in the industry. And in addition now, true to the IETF's mantra of running code, Alliance also works on specifications and APIs, is actually doing a lot of work now to turn those best practices and specifications specifically into APIs. And they're doing that by establishing an open source platform. Alliance calls this an SVA Labs initiative. And I think the following slides gives you a little bit more in-depth view of what that is. So if we look at the SVA Labs from the streaming working groups, the open caching working groups point of view, the open caching is, I don't know if it's a fancy name, but it really is something same as the concept within the CDNI, where you have an upstream CDN, which can be a commercial CDN or even a content provider, and you have a downstream CDN, which can be an ISP. So it really is using the CDNI RFCs in terms of how an upstream CDN can delegate content down to the downstream CDN in cases where it decides that that's the best path to do. So open caching is really leveraging CDNI RFCs, and the concept is very, very similar, and you have really three main pieces within the open caching architecture. What you have is the control functions that are within the upstream CDN, and you have the corresponding control functions within the downstream CDN. And then you have the open caching nodes, which are nothing but really distributed caching or CDN environment within the downstream. OCNs are what you see down below there that are distributed through the network footprint. So it distributes the content easily. And the APIs basically connects all the dotted lines. So what we're doing is that identifying all the key functions, laying out the APIs, and then we want to open source those and make them available for industry for collaboration. In addition to that, the working group has set up a test bed where we are testing features such as client stickiness. What we have seen is that some of the media players don't always stick to the last redirected source. So the behavior is not very consistent. So we've had some conversations previously in IETF on this, but I don't think we had enough data that we could bring back to pinpoint exactly where the problem is, whether it's the standards or whether it's just the implementation of those standards, where the inconsistency is. So what we're hoping to do is that run through our test bed, generate enough data and learn from it and see if there's any issues that point towards the standards. And if so, then we can bring it back to the IETF. Okay, and just to kind of give an idea on what really open caching has done so far, from using the CDN RFCs, really there are three major areas I would say that we can publish the APIs. One we would call as the service provisioning APIs, and these would be both directions coming in from the upstream CDN to the downstream, and also in cases from downstream CDN functions down to the OCN. Footprint and capacity is usually going up from the downstream CDN to the upstream CDN, providing the footprint information so that the localization can happen easily. And then the content management APIs, these focus on coming in from the upstream CDN to the downstream CDN specifically for managing the content down to the OCN level. We also have APIs which we have not standardized them, either because companies felt that some of this was just not quite there yet. And in some cases, these are very specific to feature and functions. Logging is one such API, basically billing and performance-related APIs that we have. And then the capacity insight, which would be something that the downstream CDN can advertise to the upstream CDN so that they can figure out how to allocate content in future. So these are really the main APIs functions that we have. And the intent is to make these available through the open API with the hope that we will get a wider set of contributors also. These would be really RESTful APIs, and we plan to support in multiple languages. So just to kind of bring all of that together, the intent is that I think we have done enough work in terms of where the technology is, and now that we have the information enough to publish the APIs, our hope is that this will increase adoption, also encourage collaboration from the industry, and as we publish these APIs, one of the core benefit we also look at is that we can bring back the feedback into the IETF. And we have done that based on the open caching implementation. We've got a couple of RFCs that are within the CDNI working group these have been accepted as the working group documents, and they're just progressing through the typical process of working group evaluation. I think with that said, that's all I have, and open for any questions.
Great, thank you, Sanjay. I guess one starting question I have with regards to, you've outlined a lot of the work that's related to the CDNI work. Have you provided an update to the CDNI working group, or what's the status there? I mean, they don't seem to be meeting this week, but...
Have you provided so we're working closely within the so the documents that I listed out. I realize that you're working with the CDNI work. What I'm trying to get at is that this sort of provided an overview of how industry is using the existing standards, and it strikes me that that presumably would be interesting directly to the CDNI working group, or maybe they're focused on the work that they're getting done and don't have time for these industry updates. I mean, I'm trying to just get a sense of whether or not. Some of Kevin Ma, from one of the co-chairs, has been in the loop on what the SVA is doing, Streaming Video Alliance is doing, and he's provided some input and guidance as to how we should be looking at, coming up with the work. So yeah, he's given us some input and guidance.
Right. So then I guess my takeaway is from what you're saying is that this is a useful place, a useful venue for IETF in general to have an update on how the CDNI standards are being used in industry elsewhere without getting in the way of the actual CDNI work.
Correct.
Okay. So with that.
Hi, Aaron Falk again. Minor comment. Could you take a look at the slide that's on the screen now? No, just go look at the screen. Turn around. Look up. Can you see the link?
No.
No, neither can I.
Yeah, well, this is the supposedly a new fonts that in the color scheme that the SVA came up with. I really don't like it, and you just can't really read anything on it. So, yeah.
Perhaps you could send some feedback from the IETF
yes,
on.
I take that feedback. Thank you. I've already given this feedback to them, but certainly this is helpful.
Yeah, I think you just got 30 more feedbacks.
So I think we have a clear message from the IETF back to the SVA. Your template.
Fix your fonts, yes.
I didn't. Those aren't my words. I do have a comment from the Jabber Room. Chris Lemon says, it's been a few meetings since the CDNI met, and the CDNI work is mostly proceeding on the list.
Right. Which makes sense. I just wanted to make sure that, I don't want Mops to get in the way of other work. Okay. Any other comments or questions? All right. Thank you, Sanjay.
All right. Thank you.
Hello. Hey, so Glenn Dean from Comcast NBC Universal. Wearing a different hat right now. So I was on the program committee for the recent SMPTE 2019 technical conference. It was a very interesting experience, and what I want to do is provide some feedback or some sharing of things I observed at that event that I think are relevant to the IETF and will hopefully spark some interest and work here and some lessons. So for those who are unfamiliar with it, SMPTE is essentially a standards body that focuses on what they call professional content. Typically, it came out of the TV world, but it involves both production. A lot of studios that don't do TV but do movies as well participate in SMPTE. So it's really professional creation of content, professional distribution of content, and that whole thing. One of the things they've been very engaged on for the last few years is a change from an old transport protocol called SDI, which is what all the equipment in a studio historically was connected with, into things that are IP-based, which are very much using IETF-based technologies and protocols. So one of the things I wanted to bring back here are observations of where that is right now. So that's clearly still ongoing. There's still a lot of studios out there in the world because they got to replace a lot of equipment that are still migrating to 2110 and going on to IP networks. But a couple things that really came out of the conference that people found interesting to talk about and really engage on microphones were the challenges of building IP networks for media. There were several people that gave talks on network architectures that were designed entirely to allow for extremely high bandwidth, low latency connections between editing stations, editing bays, cameras, and recording devices and storage bays and clouds. It was, a few of the things as a network guy made me cringe when I saw them because, some people said, well, you don't want to build lovely multi-tiered hierarchical networks in your shop. You want to build one big giant flat network where everybody's on the same segment so you can get high bandwidth. It made me cringe. Relevant to the IETF, there may be some guidance work that we might want to draft some materials on for best practices of how to build such networks. And I realize that crosses a little bit in the operations thing. But we have the expertise here in this. So for future work in this group, that might be an area we want to sort of tap into and play with. The second one was something which kind of surprised me. Even though I do live in this world, I didn't realize how much focus people really had on time still. There was numerous papers that talked about time, and this has been brought on because the old protocols did carry time information around with them, and all the devices then were able to synchronize and be engaged and synchronizing their actions, but also when they blend content together in pieces, that all worked really well. Under IP, they lost that. And so one of the things they've been trying to figure out, 2110 did add in mechanisms for sharing time, but the time sources are then becoming a problem. And so, it's a complex environment. They heavily have endorsed PTP, which is a time standard, of course, if you're familiar with it. There was other mechanisms, though. They didn't lock into only P2P. There's other ones that they are proposing discussing because they have a lot of scenarios where they're offline, or one of the scenarios that was brought up was if you're trying to source from GPS information and your GPSs all go down where your antennas are covered in snow, you have a bit of a problem. How do you deal with that? It's some new work that they were trying to get other parties to take up. So likewise, there may be work here at the IETF where you may want to take up around time again. Time is time. Time is coming again for time. Is there a question in the middle before I go on to the next point?
Ronnie, Evan, I had similar question because people that were trying to transport it depends how you transport the media, and they were trying to transport the media using RTP, but use the GPS timestamp, how to synchronize between the GPS timestamp, how to convey it in RTP because the precision is different of the information. So right. So I think it's important because again, it will be good also for us to know how the media is transported in order to figure out what we can do also here in other working group in order to help with this timing. It was mostly because they were sending the information from different sources and they want to combine them when in the production area, and that's where the timing, and they were getting from the camera the GPS time with that.
Yes, and to add on to that, one of the concerns that many people started raising was worries over security and integrity of time, because if you imagine a lot of the stuff that's getting produced and streamed out live, if you start tinkering with the time, you can cause a lot of problems, make screens go dark, and cost people a lot of money. Or if you want to be really nefarious, make the time go bad and then start inserting your own material that's out of sync with it and cause a lot of sort of social activism, if you will. Aaron.
I have a comment from the Jabber Room. Scott Davis says, time is everything in production. There are fine-grained time mechanisms in legacy productions that is critical to make the processes work. So I think he's agreeing with you. Do you have more? I have a comment, but I can wait till the end.
No, this is my one slide. I have one final point on this one slide, and then...
Oh, go ahead and make it.
Okay. The one thing I got really excited about when I was sitting in this conference was the number of people started to mention IPv6. Historically, the professional media industry has not been a big supporter of V6, and people started talking about V6. I was like, yes. So I just wanted to bring that back to the IETF. They're starting to listen to us, and they're getting on board, which is awesome.
That's great. So Aaron Falk, Akamai. This is the time. Well, let's see. There was another presentation that's actually been made in a few different forms this week on the ITUT 2030 vision of IP of the future. First, I want to say it looks like SMT has beaten them by looking at 2110. So that's great that, sort of getting a little further into the future. But on a more serious note, time actually appears on their list. And one of the things that sort of left me unsatisfied about the discussion there was it was more sort of a statement of we need better precision. And here, what I'm hearing here is that we're actually running better precision in lots of different ways. And so the question that I have is, what exactly are the problems and challenges that are coming out of this? I think it would be actually really useful information for the IETF to understand, like, what are the limitations, where are things not working, so that we can actually talk about some potential work here. This is one slide with a few bullets, so it's very high level, but I think that this is a very valid activity for this working group, is to try to bring in some of these challenges from operational areas on like where the protocols were hitting some walls and what they can do, where there's too many solutions, or like the stuff that Roni was just mentioning. And so I think if we could get some drafts on like, hey, here's an industry situation where, this is painful, that would be really helpful for the IETF to say, oh, well, here's an area where maybe we should apply some engineering.
I agree with you. I fully agree that. I think specifically on runtime, capturing some of their use cases, because they're thinking through them. Let's capture them, bring them over in here, and get to work on it.
Hi, Dave Moran again. So on the issue of time, historically, the media industry and the networking industry have lived in completely separate bubbles, and we're seeing sort of the consequences of those bubbles evolving in parallel. But that may be entirely irrelevant because the cloud data center people have created a third bubble, which is probably going to blow both of these bubbles away. Because most of the data center operators now have sub-nanosecond atomic clock synchronization across their entire data centers. And they don't do it with either of the things we're talking about here. So it'd be really useful to spin them into this conversation, because if you're going to run in one of those data centers, your problem basically evaporates because you have nanosecond scale time synchronization across the entire data center.
That's a good point, Dave. I had not considered that.
So if you're only worried about distribution, you're right. These groups are also worried about video production, and video production's running in data center style infrastructures. Okay. So, all right. Top point is look at what these guys are doing, because we can put atomic clocks almost anywhere now at reasonable cost.
Well, and there isn't going to be one single way people do this. It's a very diverse set of environments. It ranges from people doing field production in the jungle recording a movie, to people connected to live networks, to people in stadiums doing live streaming at low latency. So there's a lot of areas here to get really into different nits and different detail.
All I'm saying is that the way the technology is going, it is reasonable to assume you can afford an atomic clock most places.
But can you carry them on an airplane?
Pardon?
Can you carry them on an airplane?
Yes.
They'll go through TSA. Awesome.
Yes. You may need to have it in a refrigerator in order to keep the temperature stable, though.
Going back to Jake's document, I haven't looked at it, but does the taxonomy that he's looking at, is it mostly on the distribution side, or is it also on the production side?
It was primarily on the edge side rather than the center. So I think that there's So I think that the focus that I think it needs to have is more on the, do we have the capacity, or looking at the capacity gap.
Okay. Well, I think that Glenn's raising a different set of questions on the production side, and so maybe a taxonomy document to help inform the IETF on what do these environments really look at. This is kind of like what TCP/SAT did in the early days, was to try to pull in some information on what's the variation in these environments to understand from a networking point of view.
Okay, so maybe we can look forward to causing a draft to appear, and then next time we can discuss whether or not it's something we need to adopt. Good. Thanks. Thank you. Go ahead.
Sorry, I got another comment from Jabbers. Okay. That's what happens when I talk too much. Mike English says, even distribution spans, data centers, and networks, time synchronization is still a concern in heterogeneous environments. So, yeah.
All right, switching gears. Igor in the room. Here we are.
All right. I'm Igor Lubashev, Akamai, and my goal today is basically to bring some information to the people who are not following a quick working group every moment, and to share some of the observations about what quick will bring to the people who operate media streaming, who are responsible for quality of service, what kind of changes, some challenges that you'll encounter. All right. So I'm probably preaching to the choir when I say that monitoring and troubleshooting network is important for quality of service, at least to this group. But it's basically, that's what operators like to do on their network, is to be able to see delay and loss, and hopefully see it before their customers call them and tell them about the problem that they're facing. When you're looking at TCP streams, people have been traditionally looking at the sequence numbers, and if a path is symmetric, ACK numbers, and you could put together estimate of the loss and the estimate of the delay. Quick, as people are aware, is it's a protocol that's encrypting its headers. It's doing it for some very good reasons, including security, user privacy, especially in the world of migrating users who come from one network to another, and for protocol ossification reasons, which is basically trying to get the middle boxes to keep their hands away from parts of the protocol that they shouldn't be looking at. And now, so one of the goals of Quick is to be able to evolve the protocol quickly. Now, one of the alternatives is, well, if you cannot see anything in Quick, there is no signal in it, let's just observe similar TCP flows. That actually works pretty well today, because Quick on the internet represents a single digit of traffic. I totally expect that once Quick Working Group publishes a spec, and there is a number of implementations, every single browser has one, and every CDN will have an implementation, there will be a step function in the amount of percentage of quick traffic on the internet. So we'll need to develop more viable tools. And Spencer has a question.
Spencer Dawkins. Two things I wanted to mention. Thank you for bringing this work here, Igor. I could be wrong about this, but to the best of my knowledge, this is the first time a chartered ops working group has talked about this issue, and I think it's been really important. Speaking as the former area director of the SpinBit,
Yep,
But-
you're jumping ahead to my last slide, but yeah, I completely agree with you. Yes.
Excellent. On this slide, when you say just observe similar TCP flows is not a good answer, how bad is it? And you don't have to answer, but I'm saying I think that's the engineering question
Right.
that's going to really matter.
So-
as this conversation goes
So
forward.
I love that we have actually extra time here, and I'm happy to answer this question. So how bad is it? I don't know whether it's really bad today, but the TCP and UDP have very different get very different treatment by the network. It's actually not uncommon to have a network under a large UDP flood, and that's typically I would assume because it's much easier to compromise a user space application and send spoofed UDP traffic. And typically networks, what they do is they police rate limit on the UDP and their links. So you may immediately get very different performance from UDP application and from a TCP application. So observing TCP and UDP may actually diverge quite a bit.
Bernard Boba, Microsoft. Just wanted to make a comment that I think this may be assuming that Quick is used in some of the same manners that TCP is. What I'm seeing is somewhat different streaming architectures being used with Quick, such as things like scalable video coding. And one of the problems that introduces is that it's no longer sufficient to just know aggregate loss. You really want to know the loss of each of the layers that are being transmitted, and that's something you can really only get from the end systems. It's not really easy to observe that in transit, even if you were to do everything in the clear, you'd have to have the right RTP markings, and observing all of that is kind of complex. So, and I would observe that we've created a whole bunch of new metrics on the sender and receive side that actually get you much more detailed loss data than you could possibly get through network observation. So just something to think about, that this stuff isn't necessarily going to be collected the way it used to be, that it may be collected at the app layer, not even at the endpoints.
Right. I mean, definitely you cannot get everything you possibly want just by observing transport. I mean, that's the same thing in TCP world and UDP world. That's absolutely true. All right. So just a little bit of about media streaming right now is by far the biggest Quick use case. So that's why it's important for this group. And streaming is actually very sensitive to changes in round trip time and to packet loss. Now, so what is available? So once Quick basically removes all the implicit signals from the transport layer, there was work on putting back an explicit signal for delay measurement. It's a spin bit. It is available. It's in Quick version 1. I mean, of course, it's subject to user agents actually supporting, turning it on, but it is part of the standard. And it works in a pretty simple way. You just have a server that's echoing back those bits as it received from the last packet from the client, and clients spinning the bit, basically flipping it to the opposite value from the last packet that they received from the server. And you could see an on-path observer can measure round trip time in each direction. So you can be in either of the directions, and you could measure the round trip time of connections. It's using one of the bits that were previously reserved. Now it's dedicated for spin bit in Quick short header. So it's basically in the first byte. And there is a link to some more about it. Loss bit, so the loss signal is not going to be in Quick version 1. That's mostly due to timing, but there are proposals to how to do the loss measurement, and there is a quick extension draft, or maybe there will be several, that are actively in the works and will be available very soon, one of them from us, on mechanisms how to add loss reporting. And the loss reporting goal is to be able to, first of all, observe that there is loss, quantify how much, and to be able to decide, to determine whether it's upstream loss or downstream loss, which is very important when you try to actually troubleshoot the source of it. Like with a spin bit, it would be using reserve bits that are available in Quick version 1 header. And right now there are 2 drafts available for slightly different but somewhat similar methods of measuring loss. They're all just drafts on principle of operation. So actually, since again we have probably a couple minutes, I don't have a slide here. You could read the draft or look at a more extensive presentation in Montreal and TSVWG. But so one of the operational principles for one of the proposals is essentially you have a square wave. So you have a marking that alternates every n packets, and by observing that you could observe the upstream loss, and then you have another bit that's effectively driven by the protocol's loss detection machinery. If a loss of a packet is detected, it increments a counter, and if it sends out a packet, it marks if the counter is non-zero and decrements the counter. So basically, from that information, you can determine end-to-end loss, which is because it's what our protocol machinery determined. Now, knowing end-to-end loss and upstream loss, you can figure out everything else. So that's basically our proposals, mechanisms. There are others. And just before we close, it's kind of for completeness, some people said, well, one way to determine loss in Quick is to decrypt all those headers. So share the encryption keys with some trusted middle box, and now you don't have a problem. There are lots of problems with that from security perspective, from privacy perspective, but actually even from implementation perspective, decrypting a whole ton of connections real time is hard. Key distribution under lossy conditions is hard and problematic, and just not a good idea. So basically, we have to have an explicit signal in the protocol to enable this kind of measurement. And so what do we want for the operators, for people who actually care about it, for people who think it's observing loss is important to do? Number one thing is, if you have a discussion happening around you, just speak up and say it's important. That's probably one of the main reasons, as Spencer said, that we're still here talking about experiments as opposed to another proposal already in version 1, is that we haven't had a huge operator presence in Quick working group from the beginning, and so we're here now. And of course, watch for quick extension drafts. And then there are a number of links for people who are interested in learning a lot more about everything we talked about. Thank you.
Great, thank you. Questions?
Yeah, Spencer Dawkins. Colin and I have finally used the spin bit to figure out who was going to speak first. So I say thank you for bringing this to the working group's attention. I love being able to say that about ops. If I understood your point about explicit signaling, were you talking about involving the endpoints in that, or did you mean something else?
Yes, explicit signaling means that the sender of a packet puts some signal that's explicitly meant for the path for a particular specific purpose, as opposed to what we have with many other protocols. Well, TCP is a great example where there is protocol machinery that observers try to latch on and infer information.
So I'm sure this happened many times before this, but the one I'm remembering is the Marnu IAB workshop in 2015, where we were basically saying how will network operators understand what's happening to their networks. Same problem here, just different operators, which sounds like a good thing. I've never understood how we were going to be able to do this without involving the endpoints, and especially the interaction between what's in the quick invariants, so that basically you could have network operators that could consistently look at what they need across versions of quick, versus being able to ever change anything, because the point was that the invariants don't vary. So I think that, like I say, I think that you're definitely headed in the right direction, and I only wish we'd been smart enough to do that a couple of years ago, because I think you're definitely headed in the right direction. Thank you.
Thank you. So as far as invariants, that is a great question. Quick is a pretty new thing that people have not had much experience with anything like it, especially on anything like the scale. So the signals we're talking about are also quite new, that many people, or nobody has any experience at scale. So all of these things are quite experimental, and therefore that's why it's there in version 1. I can totally see if they take off as one of the important means for people to monitor their network, then they're going to be deemed very, very useful, and nobody will think of removing them from the future version of the protocol if there are no problems with them.
Hi, Colin Perkins. So Gori Fairhurst and I have a draft in the transport working group, which is talking about the effect of transport header encryption on future transport protocol evolution. One of the things that talks about is the implications for network operations and management. It's in last call in the TSV-WG. It received a fair amount of feedback, primarily from the security related people. It would be useful, I think, if this community could also have looked at and see if it makes sense, and if people have concerns or comments about what we're saying there. Draft IETF TSV WG transport encrypt, I believe.
Yeah, definitely. It's a draft that inspired some of the work that we're doing. I mean, this is actually putting bits specifically on the wire. That work was more general observation about effect of encryption.
James Gruesing, BBC. I'm not the most knowledgeable on Quick, so if I get this wrong, somebody stop me. So one crazy idea is instead of having Quick doing affirmative ACK on port ranges, switching it so we're doing negative ACK, which is what a lot of ARC-based protocols use, and then use one of those reserve bits for the signaling. This would mean the client opts into telling when there's loss in the network, but the details of how much needs to be retransmitted is still inside of the encrypted payload.
I'm happy to talk to you offline and to get figure out the details. The general gist about just the overall Quick is that it's trying to make sure that the only signals we put here are truly explicit signals about this particular purpose. So if we try to marry a little bit of protocol machinery to be in the clear, it may be different. It may become difficult, but I'm happy to talk to you.
Hi, Igor. Sanjay Mishra from Verizon. So I think this is really good. And I was at the quick meeting where the discussion did happen on this. And I know a lot of operators didn't necessarily stood up to the mic to support it, but I think it's implicitly there. And I think there's a lot of exhaustion also on the operators' part because they've stood up significantly, and Mark can vouch for that. Just to get spin bit in quick. So I think it's not lack of interest in this. There's a tremendous interest, and certainly I think the point you made, it's well taken. And I speak for Verizon, but I think other operators are also very equally interested in seeing this work progress. So I think we'll keep an eye on that and provide comments and things as needed.
Thank you.
Thanks.
Zahed, I'd like to take the comment a bit up level. So I've heard Bernard talking about a lot of loss information and other information metrics will be collected in the endpoints. And I also hear Spencer saying how do you do without involving endpoints, right? So would it be very unrealistic to think in the future that we have more a collaborative client and network in place, where basically client is helping the network with providing some information about these kind of metrics. They think I'm suffering, so maybe there is something that I cannot do on the server. Maybe something I share with the network, so network fix itself, something like that. And on that note, there is also initiative here. Is coming initiative on Musk, where you actually put some explicit proxy for quick traffic and stuff like that, where you can have some kind of explicit channel, which is basically authenticated and agreed on, where you share some form of information. And I think that is another thing that we might want to look at, or more explicit, more like a collaborative way of solving the problem instead of doing everyone does this best and nothing achieved. So that would be one way of looking at the problems. Yes.
Mm-hmm. Yeah, I totally think that people will come up with very interesting ways of solving problems. I mean, people are pretty creative around here. And if you find clients and that are willing to talk to cooperating middle box, and there is some control plane communication happening that's helping performance or anything else, it will happen if it's useful and if clients find it useful.
Mm-hmm. Hello, I am Emile Stefan from Orange. And so with Igor, we asked this slot because network operation and monitoring is based on the observation of the delay on the packet loss. And we have been, fighting in the quick working group to get the spin bit, so to observe the delay. So with the spin bit, a non-pass device can observe the decomposition of the delay, let's say on the right, on the left, and know where is the big budget. And so we are now asking to get the same thing for packet loss observation. And we are close to get something. And that is, I suppose, is going to be useful for media distribution.
Right. So, I mean, I wouldn't call it fighting, but there is definitely a quick working group is a collection of very spirited, high-spirited and opinionated people. So it's fun. But good things happen, definitely. And so like I said, there is an extension draft that's going to be prepared. We'll try to get it in time for the quick interim. We'll definitely post it on the list, and we're more than welcome, actually, very, very welcome feedback from the community, feedback on the technical stuff, feedback on the privacy implications, or whatever people find that they really want to contribute about.
Mauro Cocciglio from Telecom Italia.
As operators, we are very interested in this technology. We are the developer of the other alternative methodology, but we support this kind of measurement because, in our opinion, packet loss and delay in explicit way is very important to monitor our network. It's not also important to monitor the application, but it's also important to monitor the network, and in particular to segment the network in the many segments. Each segment is the domain of each operator, so we want to distinguish the measurement, to segment the network, to understand where is the problem. So this kind of measurement in a explicit way is very important in encrypted protocol. This is our opinion. So we support very much this kind of measurement.
Thank you. Yeah, that's a common feedback that essentially what operators want is they want to be able to, if there is loss, for example, figure out where it's coming from and to just know whom to call.
Spencer Dawkins, I did not get up here to say this, but I can definitely confirm that there was fighting in the quick working group about the spin bit. But more relevant probably to this discussion is the plus BOF that we had in Berlin. That was a tussle of amazing proportions to the point where I made the decision not to charter a working group there, which was intended to provide visibility to on-path observers. So, I mean, it's like, couldn't even charter the work. So the part where you're talking about involving the endpoints with explicit signaling and instead of distributing keys to theoretically on-path observers until the first day we do multipath quick, then they won't be anyway. But forget that. Like I say, you have no idea how important what you're proposing is.
Thank you. Yeah, I mean the slide about distributing keys to on-path observers was mostly like just don't even think about it kind of thing. Right.
Yeah, with regard to the exposure of the session key, I think it's really a bad idea, especially for the inter-domain troubleshooting. Nobody is going to share key from inter-domain. This is really important. On a more larger scope, I think with the spin bit, the quick working group is enabling a framework where end-to-end points are exposing information which integrity is protected by end-to-end. And this is something that the TSV working group should think about. Encryption is not all the part. You have integrity and encryption. And they should take care of both, not only encryption.
Right. That's actually a very valid point, that one of the things that you get from using quick headers and quick protocol mechanisms is that you get integrity protection of that signal. And as far as the endpoints are concerned, so by having endpoints engage in this, it's giving endpoints a choice to provide the signal. We hope that most of them will. All of the drafts for spin bit and for the loss bits involve a provision that mostly they're about anti-protocol ossification, but also for privacy, that a small fraction of the traffic should not have the signal exposed. It's not going to compromise, because it's a very small portion of the traffic ability to monitor it, but it will give additional protection against protocol ossification or some possible privacy implications for a minority of clients who may choose not to expose the signal.
So I'm conscious that we're sort of slipping into talking about the material and not just raising awareness. So Colin, I'll give you the last comment on this, and then we'll close this segment and close the session.
Okay, thank you. Two quick comments. The first is that in the conversational media world, there's a fairly extensive endpoint reporting framework in TCP. And clearly that's not directly relevant for this, but there may be some inspiration that you can take from the things that have been done in that space. The second is that if you're reporting on endpoint, if you have endpoints reporting on the behavior of an encrypted protocol, there are some interesting questions about the integrity of that and whether the network can trust the reports to be accurate. And thinking about whether there are ways of somehow validating that the reports coming from the endpoints match what's actually going on may be useful.
Yeah, that's a great question. Yep. I know that Connect's working group has done some work in that regard previously. I mean, there are not enough bits for that, but that's a very valid point. And I mean, theoretically, you could have a malicious TCP sender who is sending TCP packets that look like gratuitous loss. So that's not an entirely new problem for that space, but it's valid.
If a TCP sender tries to manipulate whether it lost, the information about whether it lost packets in terms of the acts, it affects TCP behavior.
Right.
If a quick receiver sending reports does the same thing, it doesn't affect the quick performance.
True. Correct.
And that's the difference.
Yep, that's true.
Okay, so my takeaway is that our awareness has been raised on this topic, and that the work is currently being done in the quick working group. So the action item for people here is to keep an eye on the work being done there and contribute voices and opinions as appropriate. And then I guess if further more cohesive input is needed from people interested in video, we may at a future time decide to try to articulate video needs with regards to this. Yes, Ronnie.
Just to be more precise, it's currently there's the work now in both in IPPM and quick working group, and I assume that today in TSV area they will try to discuss where to do future quick work. So for that, if people are interested in this work, they should voice their opinion where it should be handled. Mostly because of the overload of all these working groups.
Right. We're quite sure it shouldn't be done in this working group, so that's one off the list. Right. Okay, great. Thank you very much. So now we've done one of these Mops working group meetings, and hopefully people have a better sense of some of the type of things that we can discuss, and you can be thinking of things that we should be bringing to the table when we next meet. So I will ask you to do that. If you're not on the Mops working group mailing list, you can certainly go ahead and join. And my last plea before we have a word from the area director is, if you haven't signed the blue sheets, please make sure you do before leaving. Eric.
Yeah, Eric Vink, responsibility for this group. I'm quite happy with the first meeting. There are at least the timing and the quick topic that are coming between the video cross area. So I'm quite happy with this.
Good.
But don't sleep on this, right? We need to continue.
Yeah, exactly right. Let's keep the momentum going. Okay, so blue sheets are up here for anyone who needs them. Apart from that, go warm up. Thank you very much.
And see you in Vancouver.
Thank you.
One thing I completely forgot to not mention was that we just submitted our